Our next speaker graduated with the honors in computer science from Nnamdi Azikiwe University. Is an experienced information security specialist, skilled in network administration, firewalls, technical support, and network security. I'm expecting a round of applause at this point. He has worked with Philips Consulting and currently works as the Chief Technology Officer, that's the CTO at Ennos. Ladies and gentlemen, it's my honor to introduce the next speaker whose talk is titled Putting Sec in DevOps. Please welcome Mr. Goodness Obani.
Good afternoon, everyone. I don't know where my friend here got all this information. I felt like a celebrity overnight. Yeah. It's so nice to meet with you. It's a very beautiful thing to meet with the community. I'm not a developer, but I love developers, DevOps engineers in the house, and everyone with me present. And it's so good to be with you. Yeah, the reason why I love you, we in the security team, or in the security field, love developers, is because you are at the heart of business. Every business that functions today is because of you. And that is why we want to work with you. Because what I want to talk about is security. Putting the sec in your DevOps. Motivational speakers will begin by telling you that 1 + 1 is 1. Yeah, they always do that. When they want to talk about marriages, they want to talk about how husband and wife are supposed to be together and 1 + 1 is 1. Although recently my wife is telling me that it's actually 1.5, the half representing my problems. Now, I'm going to introduce another motivational equation. You must have, all everybody in this house must have heard about DevSecOps. And we understand DevSecOps as a combination of DevOps and security, right? But now I've come as a motivational speaker. And we're here to tell you that DevOps plus security is still DevOps. Now those who are in favor of this motion, and those who are not in favor of this motion. So the truth is that all of us are really in favor of this motion. Those of us who don't support this do not really understand the core of DevOps. And that's the truth. But the different speakers who have come to speak have spoken about the core of DevOps. And the last one just spoke about agility, automation. And that's how it all began. The traditional waterfall method, when people worked in silos, when different teams, you have the development team, you have the change management team, you have the infrastructure team, you have the operations team. There was also the security team. And security was also seen as an afterthought in every development process. But then we had transitioned. We went DevOps. We started speaking DevOps. And then we began to sync the different teams, the development team, the operations team, the infrastructure team, the deployment team, and we called it DevOps into one continuous cycle. What we forgot to do was to include the security team somehow along the line. At the end of the day, at the deployment and operational parts, or the monitoring part of the DevOps cycle, we now still brought security as an afterthought. At the end of the day, the purpose of introducing DevOps, which is for agility and speed of delivery of applications, was forfeited because we are still going back to that traditional method. So the point is, we need to have a shift in our thought. The reason why we call it DevSecOps is just because we want to begin to make people aware that it is really DevOps with security in mind. Automation. The security team, right from the beginning, and I'll tell you these stories that we have had over time, in most times when we are having engagements with different organizations, because we have been having engagement with different organizations, developers and security teams, well, they always have, there's this loggerheads we always have, it's fighting every time. Because the developer is always thinking, how do I bring my code functionality? How is it going to work? The business person is talking to the developer and saying, yes, it must work this way. As long as it's working, we're fine. The security team is always lagging behind. It's always telling you, no, come back, you have to come back, you have to fix this, you have to fix that. And so there was no sync between the developers and the security team. But as security has evolved, it is not more the traditional security where we would have to be calling developers to come back. Because, I mean, if you're a business owner, the only thing you're interested in is in the functionality of your business. Every other thing should point to that particular goal. And that is what we, as in the security field, want to do. We want to also support that agility and speed of delivery of applications. And that is why we are saying that security should be integrated at every phase of the DevOps continuous cycle. And I'm going to give you a use case of what we have done, because this is going to be very brief because of the limited time. We worked with a bank. They were about building an application. I mean, of course, you know, those of you who are building fintech solutions for organizations, you understand that most of these fintech organizations have requirements from regulatory bodies like your CBN, your NITDA, to comply to regulatory compliance standards and frameworks. And one of them is the PCI DSS and the ISO 27001. And so because of this compliance, the bank had to call us in to come and work with the development solutions team, we call it the DevOps team, to come up with an application. And now the goal was to be able to produce this application in the shortest amount of time. For the deadline was just 1 month, but with security in mind. There have been failed projects along the way, because there's a back and forth between the security guys and developers within their infrastructure. They had a security team, an IT security team, and so most times there's always this loggerhead. So security team was always delaying this process from happening, the application from happening, and so the project will always fail. And so they had to bring an external consultant, which was what we came to try and do. So with automation in mind, with agility in mind, we set out to work with them. First was to understand this cycle, this continuum of DevOps. The question will be, at what points in this DevOps continuum do we integrate security with the focus of automation, or the focus of agility? And we understood that 3 things of an organization, and this is very important. Every organization that is functional today is made up of the people, the processes, and the technology. And that's what security tries to achieve when we begin to implement security in different spheres, whether it's network security, database security, and application security. And so the first thing we did was to start defining the process for development. The first stage in development is always your design. Now, you see, the problem with design is that most times, especially in the bank, in these financial institutions, nobody really sits down to design anything. You just call from a particular business unit. Hey, we need to develop something now. We connect to this particular application, or connect to a particular an airline, need something to integrate. Now, we need it now, immediately, start working, and all that. So that has always been the problem. There has been functional design requirements, but there has not been security design requirements from the start for whatever applications that were supposed to be developed. And so the first thing that we did was to define security processes for the organization. Processes that cut across people, that the developers, to the people who are going to deploy the application, to those who are going to continuously monitor the application. The processes that we built were taken from PCI DSS requirements In the PCI-DSS requirement 6, it stipulates exact things that developers must do to comply. Things like checking their code at code level. Things like making sure that the different teams are able to integrate security into their different workflows at every point in time, both unit testing and when the application is built. And so that's one of the things that we began to do. So at the end of the design phase, we came up with security design requirements, which were passed on to the different developers, and they had to move on with it. Next, we had to look at the places or the technology to be implemented. The technology to be implemented at each point of the continuous DevOps cycle. Now, speaking about technology to be implemented, the whole application security testing that you know today, because of course application sits at layer 7 of the OSI model, which is always the part where hackers like to attack, because it's always the user end, it's always the user front end. In fact, recently, because I just conducted, there was this DDoS attacks. The DDoS attacks, they say, come from only network. So you only have DDoS attacks on your network and all that. And so it's now cascades to your application goes down. But now we're beginning to see slow DDoS attacks on the application, the layer 7. DDoS attacks happens on the layer 3 of the OSI model. But we're now beginning to see slow DDoS attacks on the layer 7 model, the layer 7 application layer. So even on things like search queries, people can be able to replicate DDoS attacks that happens on the layer 3 to the layer 7 of the OSI model. And that is why in the whole application security testing spectrum, what we did was to identify different application security technologies. So we have the SAST technology, which is called Source Application Security Testing, Static Application Security Testing. We have the DAST technology, which is the Dynamic Application Security Testing. And of course, we have the Runtime Application Security Protection. To begin, we began by educating the developers, because which comes back to the last part of an organization, which is people. Because you understand that an organization may have the best processes and the best technology, but you see the people. When you don't have, the people can either begin as best and end up turn worse, or begin worse and end up more worse, or begin as best and end up as best. And those best people do not always stay in the organization, they always leave. So that is why our main approach was targeting the developers. What exactly was the problem? The adoption of security. There is no developer in this world that does not want his code to be secure. But the process of making it secure has always been the problem. So the culture was what we tried to adopt. That security culture. And there are so many ways to build culture around adopting security into development processes. We began by designing games. Some little games where you, as a, like you just like this, what they call it, what they gave this guy, normally the person is running, lion is chasing him, and all that. Temple Run, yes, Temple Run. So this kind of game. So what we are doing is that you are the developer, you are running. As you are running, you are seeing different security issues. Is like exploit injection. You're supposed to do something to evade it, and then you move on to the next phase. So it's like level by level game that we developed, that we designed for developers. You see, that kind of thing is simple. It doesn't matter. But the truth is that at the end of the day, they began to adopt that culture. They began to see the need for them to start saying, okay, this is important. SQL injection is important to be removed from my application. I need to use parameterized queries. Oh, I need to be able to implement secure containers and all that. So training was important, and that's one of the things that we tried to do. Training from implementing security during the development process. Then of course, the technologies that we now use. As you can see, we decided to see, we asked ourselves, at what point do we integrate security throughout this cycle? Do we implement different technologies at each of the different phases of the development? Or do we develop, or do we implement one solution that will integrate into the different phases of development? Now, security experts have different approaches to this, because security experts will tell you that you cannot have one solution fit it all. In other words, I have one solution that can take care of issues at all different layers of my OSI model, or that can take care of this, can take care of that, can take care of that, just in one solution. On the other hand, we understood that the reason why developers were not really keen on adopting security was because they had to use different security solutions at a different point. So imagine finish developing, you scan your code. After that point, you go to you're in containers. You use another solution. You move to the deployment. You have to use another solution. So at each point in time, you're using different security solutions to achieve security. That becomes a problem. That increases the time to deploy. So we say, okay, let us use one single solution. A solution that has these application security testing capabilities that can integrate to the different points, especially in the DevOps environment. They used a job for the DevOps environment. Of course, we have different containers we're using for development. And then we began by implementing checkmarks as a solution that integrates to the different parts of this DevOps environment. And what we're able to achieve is that from the development part, when the guy is developing, normally the IDE is informing you of bugs or of security. Yeah, of course, if your code is wrong and all that, identifying for you, putting it in red from your IDE. Checkmarks is also doing that for you. So you don't want to, at the end of the day, finish writing a whole module of code, and then you now have to first go and check it in. After the functional test, you come back and tell you that there are vulnerabilities in the code. You want, after each module of code, as you are fixing the functional issues or the security bugs with that particular module, you're also fixing that security issue as it is going. That's the point of integration to the IDE. Then, of course, during the checking process, when you're checking in the code to the repo, the repo that was used was, of course, they have a repo that they built from Git, rather than using the Git hub. They had a repo that they developed from using Git. So they had their own source code repository in-house. And so one of the things we did was to also integrate to that repo, so that at each point when each of the different developers are checking in their different codes, and it is doing, of course, version control testing and all that to make sure it is the different codes can be built, can be managed together. It's also doing that security testing at that checking process. So, because vulnerabilities can be identified at the IDE level, but can also be identified at that checking level. So that's another thing that was built at the repo. The same solution was integrated to that repo. Then the next would now be at the containers, because they made use of containers too. Now there are issues with using containers for development. You know, first of all, of course, the business tells you that containers are useful because they help to take a model of how the solution and, of course, the different dependencies are going to be deployed. Most of the attacks that we see happening today, and this is happening because, you see, most times the hackers they are no more interested in going to where the production environment is, where it has been deployed, servers and all that, to go and start hacking. You know, a lot of security implementations must have been made there. So they target containers, those images that you go and download, which you want to build your code upon, and you want to build them together. And that's what the attackers try to attack. Because their focus is looking at those dependencies that you are trying to use to build, so that you have fast code delivery or fast application delivery. Those dependencies, those open source libraries that are used for development are what they're attacking. Whenever we see any attack, like the one that happened with what they call this dirty cow exploit, the dirty cow exploit that happened, it's focused, that attack was focused on the open source dependencies that was used for the containers that were used for development. And so, when using containers, which is good for development, it's also very important to be able to integrate security into those containers. So, for example, identifying open source projects or open source libraries that are vulnerable at initial, and doing what we call virtual patching. Now, it is possible, it is very true that those are all, there's no library that will not have one or two vulnerabilities. And it's also possible, it's also true that it is impossible to remediate all the different vulnerabilities. But it's very important that virtual patching has to be implemented for the different open source libraries, such that even if the open source libraries are used for the application, there will still be protection for your application, even if vulnerabilities are associated with that particular open source. And that's one of the things that we did to implement. Then of course, in the deployment method, we also implemented tools for the deployment where the application was at production level. Tools that log different the different activities that happen at that production level. Still to that, our code exposure platform, which was Checkmarks. Then there was also the WAF monitoring, where we implemented the web application firewall to protect the application from attacks. So you see, the whole idea was at each stage of the development, at each stage of the whole DevOps continuous cycle, we worked with the developers to ensure that just using one solution to integrate the different points of the DevOps cycle, we can achieve security. So that at the end of the day, they are able to produce solutions or applications, we were able to produce an application that met time and that was also secure, which was the whole idea of DevSecOps. I am going to stop here, because you are telling me that I already have, my time is really up, and if you have questions generally, you can be free to ask at this point.
Thank you guys for not making me ask that. Well, I'm going to ask again. Another round of applause, please. So we're just going to take very few questions. I need to see those hands up so that we can do a quick count to know who has questions. Questions. That's one. Questions, two, and one more. Okay, three.
You said you do code analysis. Is that correct?
Yeah.
Yeah. So how do you do your code analysis? Is it through static analysis, dynamic analysis, or how do you go about it?
Okay, can I answer that? I'll just wait for that one. Okay, so of course we spoke about the different application security testings: static analysis, dynamic analysis, and the runtime application security protection. So like I said, using one solution, because of course there are different solutions that speak to different things, because they work on different technologies. The static analysis speaks to the at code level and is inspecting, just like your normal ID is inspecting the different lines of code. The static code analyzer inspects different lines of code, checking against its own library of identified or global vulnerabilities. Then for the dynamic application security testing, it is looking at the code when the code has been built. So in this case, it is now sending scripts in the form of scripts, Python scripts, for example, to the application and waiting to see the response to that particular, how the application is going to respond. Based on the response, it's going to identify what vulnerabilities are there. So using a combination of both static analysis and dynamic analysis, because it's possible that some issues can appear in the static analysis which may not even appear in the dynamic analysis, e.g. blind SQL injection which can appear in dynamic analysis but may not even appear, may appear in static analysis but may not appear in dynamic analysis, which we call blind SQL injection, and a lot of other applications. So using a combination of SAS technology and DAS technology, and also what I call runtime application security protection for the application in your container, helps to integrate the three different application security testing methodologies will help to protect the application using just one solution.
For that good session. Quickly please, you're aware of the PPVCD attack on WordPress sites. A similar example of hacking using dependencies where login were infected.
Sorry guys, I don't know, are you hearing him? I'm hearing him, but I don't know about others. Can you just... Okay, so looking at such kind of scenarios where attacks don't target vulnerabilities, but they target the dependencies. What the best strategy do you think one can adopt to be very sure
he doesn't get hooked in trying to use this dependency. That is one place. Two is, I know you'll be aware of the recent DDoS attack on Azure, despite their own DDoS protection service, and they claim that it was the protection service that slowed that reduced the impact of the attack and essence. So how reliable is it for a user to depend on that service when even they themselves got? Number three is, I know you likely be aware of Pato Auto networks providing cloud security service. How reliable is it depending on a solution like that for an wholesome protection of your cloud services from what point, instead of just like you said, having to use so many tools. So I know you're aware of Pato Auto.
Yes.
Yeah, so how dependable are services like that? Thank you.
Okay, thank you. It's impossible for us to remediate because we're trying to build an application that's going to turn out in the quickest amount of time. So virtual patching was what was implemented. What you need to implement for your application. So the dependencies sit around the application, help your application to run. But then your application is put in a runtime application security protection. So that at runtime it is running, it is functioning, but then it's also being protected from the dependencies that may affect it if a vulnerability tries to exploit those vulnerabilities. Your question about dependency on cloud application, Azure, yes. I just want to ask, somebody mentioned this. If we're using Azure, for example, what is the backup? Look, the truth is that all the different cloud dependencies I'm going to tell you that we have 99.9% uptime and all that. That's so true, and it's all in the service level agreement. Has anybody here read Microsoft Service Level Agreement? Microsoft Office. The truth is that nobody reads service level agreements, because in that service level agreement, I can tell you here that you cannot hold them for anything that is going to happen to you. What they are doing by providing you those services is that they are sharing your risk. It's not a risk transfer. You are sharing the risk. Because at the end of the day, whatever happens on your own end, you are still going to be affected, whether you like it or not. So that's why we also advise disaster recovery, business continuity for your critical applications. So as much as having your container database, put a container for a database for your applications, have a replication of all these different things in your own site or in different sites, such that whatever happens, yes, of course, it's not a service level agreement to them. Something will surely happen to them. There is no application that cannot be attacked. There is no application that cannot be exploited. Somebody say that there are two organizations, the one that knows that they have been hacked and the one that don't know that they have been hacked. So the point is, you need to know where you are standing. At this point, you don't know whether you have been hacked or whether you have not. The point is that every organization has been hacked. But the truth is, you don't know whether you don't know or you know. But the truth is that you have been hacked. So the point is to implement disaster recovery strategies, implement business continuity strategies for measure your critical applications, because implementing disaster recovery is actually a very, very costly thing. But just identify what is critical for you, for your business, especially for those who are running financial things, stuff. Identify what's critical for your mission critical applications, and then define business continuity strategies for that. And I did not remember the last question, sorry. Okay, one solution for fits all. So that's why I said the different experts. The truth is that in this world, you don't have one solution that's of course everybody has his own expert solution. Everybody claims to have an expert solution for it. And I told you that when it comes to security, there are those that say that you need to have one solution that fits all. There are those that say that would be like the first point. And if that happens to you, then if an attack on that particular solution means a compromise on every other thing that happens behind. Then there are others that are proponents of the fact that we don't need to have so many solutions, so that developers can begin to imbibe that culture of having security. So if we just have one software code exposure solution that integrates the different points, SaaS that does static analysis, or does dynamic analysis, and does runtime application security protection, and that application in itself is also well protected, because the security solution in itself, the security solution can also be exploited. And that security solution is well exploited, then that can also help to make sure that security culture is imbibed in the hearts of the developers.
Just like
DDoS attack. So I know we've read about how to mitigate that. Well, from your own personal experience, have you ever experienced a DDoS attack on an infrastructure, and how did you go about resolving them?
So just last week, I was with one of our clients that just experienced it. I'm not going to call the bank's name. I am not going to do that. But just last week, I'm giving a view last week. So those of you who are using the banking application will know what I'm saying. I'm not calling any bank's name, please. It's from to my client. So it happened. Now this happened, and he had a web application firewall that was in-house. The web application firewall is supposed to prevent DDoS attacks. You know, the fact is to first understand how the DDoS attacks happen. Normally, what we understand as DDoS attacks is when, from a particular IP address, I start sending high amounts of data or traffic to a particular application that has only been configured either with the switch on the firewall that sits in front of it to only accept a particular amount of data or traffic. So I send more than is required. Normally, every next generation WAF is supposed to see that and able to block that IP address. But, and this is very important, there is also the slow replay client DDoS attacks. Now with slow, with that particular DDoS, that particular type of DDoS, it's looking at, because normally we accept on my web application, for example, my internet application, I am only going to be accepting small bytes of traffic that are coming from a particular user. I will accept this as legitimate because I know that this guy is actually doing a legitimate transaction on my account. But what happens when that legitimate transaction of only 2 kilobytes is spread across 50 million people that are doing that are sending small bytes of traffic to my web application, which is accepting. So at the end of the day, the WAF is looking at it. The web application firewall, which is implemented for the application, is looking at it as legitimate, allowing it to pass to my application, but it now allows more than it's expected on that particular application, and it ends up crashing the application. So, one of the things that we do in this particular case is to implement anti-DDoS protection for these web applications. An anti-DDoS application is not just looking at traffic that are coming from just one particular IP address or a set of IP addresses that has already been blacklisted and looking at whether more major traffic is coming from it. An anti-DDoS solution is also looking at, is inspecting the actual traffic that is coming from each of the different IP addresses that are connecting to the web application and checking if the traffic that is coming, whether it is a legitimate transaction or not. It's not just looking at the fact that the WAF is only looking at the amount of traffic, so this is 2 bytes. It is, for us in our version, when we see 2 bytes, we know that it's legitimate traffic. But the anti-DDoS implemented solution is also looking at the exact information or the exact data or traffic that is being passed to know whether it's actually legitimate, the person doing a legitimate transaction or not, so that it allows that to pass. The anti-DDoS solution is also monitoring the dark web. The dark web, of course, the dark web is, look, we have a lot of guys in the dark web who are creating, even the dark web, they even have their own anti-DDoS solutions too, the dark web. They create their own security solutions. They have lots of credit cards. They have lots of things they have developed. So they can go and create a clone of your application, of your environment in the dark web. We just saw that to one of the banks. They can create a clone of the network diagram existing in your environment, in your infrastructure, all the firewalls, all the IPS, the intrusion protection detection systems that you have, all the endpoint detection recovery strategies you have. All your idea will clone your own environment in their own environment, simulate attacks. If it's successful, then they can start propagating to you. So what anti-DDoS solutions is looking at is trying to even monitor activities that happen on the dark web. Because truly on the dark web, at the end of the day, you see on the dark web, you see people who are cloning your applications and preparing for attacks on you. They will even send you a mail like what happened last week. They sent a mail ahead to the head of IT, the management, informing them of a particular date when they are going to attack. And on that particular date, they did so. Now they in their mind are thinking that WAF, because they have bought WAF, they are really ready for the attack. But at the end of the day, their service is crashed. Later on, they began thinking about its implementation with the DDoS solution. So DDoS solution, and not just any DDoS solutions, because when people want to buy solutions, the marketing guys come and start preaching. There's a lot of stories. This, you can do this, you can do this, you can do that. First, understanding the technology of how a DDoS solution is supposed to work is key. So it's not by what the marketing guy wants to come and tell you, we can do 1, 2, 3, 4, 5. But understanding the technology, how it's supposed to work, and then analyzing whether the solution is fitting that particular description, and then purchase of it. So these are ways to protect your applications. Yeah.